Welcome back students. Now we are going to start study about condensation polymers. Now condensation polymers are those polymers in which polymerization reactions involve a condensation reaction. Now condensation reaction is a reaction in which two reactants come together, they combine and they involve elimination of simple molecules like water, alcohol or HCl. So we'll study about condensation reactions in more detail in this video, and mainly we will focus on polyamides and polyesters. So let's start. Condensation polymerization. It is also known as step growth polymerization, and it involves repetitive condensation reactions between two bifunctional monomers. Okay, we know that a condensation reaction is a reaction in which two reactants come together, they combine, and the combination results in elimination of simple molecules like water or alcohol, etc. So in condensation polymerization, condensation reactions takes place and it results in loss of some simple molecules as water, alcohol, HCl, etc. and leads to formation of high molecular mass condensation polymer, and the example is Dacron. And it is formed like this. We have N molecules of CH2OH, CH2OH. This is ethylene glycol. Ethylene glycol. This ethylene glycol combines with this molecule, which is known as, let me write first, terephthalic acid. These two molecules come together, they undergo condensation reaction. Condensation means it involves elimination of water molecule, and the compound which we get looks like this. It is a polymer with CH2, this part, then an oxygen, then carbon and oxygen here, and a long chain which is known as Dacron. So this is an example of condensation polymerization. Next up, polyamides are formed by condensation reactions and they possess amide linkage, and they are prepared by condensation polymerization of diamines with carboxylic acids, as we have just seen example, and also of amino acids and their lactams. The first example is nylon 6,6. It is a very famous polymer which is used in making sheets, bristles of brushes, text, and also in textile industry. And how it is formed, let's have a look. What happens, it is formed by combination of HOOC. We have studied about this earlier also. Adipic acid. This combines with this compound H2NC26 NH2. This involves, yes, elimination of water molecule, and we get this NH, then CH2 4 times this part, then again NH, actually it's this part, it would be 6 here, then this NH, then CO this part, then CH2 4 times, and again CO. This is nylon 6,6,6,6 because both the monomers have 6 carbon atoms. Here also 6 carbon atoms, and here also 6 carbon atoms, so this is known as nylon 6,6. Next is nylon 6, which is used in manufacturing of fabrics and ropes, and actually it is formed from caprolactam. Caprolactam is a complex compound. Its structure looks like this: NHC, then a carbon here, another carbon, another carbon, another carbon, then another carbon with an oxygen, and these all are CH2. So there are a total of 1, 2, 3, 4, 5, 6 carbons. This is known as caprolactam. At 533 to 543 Kelvin water, it results in formation of a polymer CO, then CH2 whole 5 and H. This is known as nylon 6, which is prepared from caprolactam. Next are polyesters. That means they are polycondensation, which are these are polycondensation products of dicarboxylic acids and diols. Example is dacron. Just we have studied about this dacron, which is formed by by heating a mixture of ethylene glycol and tetraphthalic acid. We have just studied, but once again we can write it in this way. It is formed by heating HO, CH2, CH2OH, which is actually ethylene glycol, and HOOC and COOH, which is terephthalic acid. On heating we get, yes, O, CH2, CH2, O, C, CO, then a benzene ring, CO, and this is dacron, a polyester, and it is basically the catalyst which is used for this reaction is zinc acetate antimony trioxide. And dacron fiber is actually very useful. It is used in blending with cotton and wool fibers. We know polyesters are used in fabrics. It is used as glass reinforced material in safety helmets. So polyester is very famous polymer which is used mainly in textile with wool and fibers. Next is bakelite, which is actually phenol formaldehyde resin or phenol formaldehyde polymer. Why so? Because in this, phenol reacts with formaldehyde to form this compound, or this mono di or tri-substituted compound, and when this is further reacted with in the presence of acid or in acidic medium, it combines to give a polymer chain, which is known as Novolec. And this Novolec, when it is further heated with formaldehyde, undergoes cross-linking to form a infusible solid mass which is known as bakelite. You can see it has cross-linkage, and it is used in making combs, records, electrical switches, and handles of various instruments. Next up, actually, there is a term plasticizer. Plasticizer is an organic compound that dissolves in polymer and allows the polymer chain to slide past one another. This makes a polymer flexible. And here are the examples of some plasticizer. It is dibutyl phthalate. It is used as a plasticizer. So if in exam it is asked that what are plasticizers, so now you know that plasticizer is an organic compound that dissolves in polymer and allows the polymer chains to slide past over one another. Now melamine formaldehyde resin. Just like we have studied about phenol formaldehyde resin, it is melamine formaldehyde resin. First of all, the structure of melamine, it is like this: a nitrogen here, amine, amine, another NH2 conjugated system. This is melamine. This reacts with formaldehyde to form C2N NH CH2OH, which are with a conjugated system like this, and NH2 here, and this undergo polymerization to give rise to a structure like this. NH with n number of chain, and this is known as formaldehyde, melamine formaldehyde resin, which is used for formation of unbreakable crockeries. Now, biodegradable and non-biodegradable polymers. As the name suggests, biodegradable polymers are those polymers which are easily degraded on their own. That means they are affected by the action of microbes. They undergo degradation by the action of microorganisms, and all the natural polymers are biodegradable, like PHBV polymer or dextrine or nylon 2, nylon 6. Apart from that, there are many more like protein, proteins or nucleic acid. These all are natural polymers, synthetic polymers. These are natural polymers, so these all are actually biodegradable. They can be decomposed by the action of microorganisms, while non-biodegradable polymers do not undergo environmental degradation by the action of microorganisms, and that is why they are harmful as a solid waste and they cause pollution, because they are not degraded. They remain in the earth environment for long period of time. And all the synthetic polymers are non-biodegradable, like bakelite, PVC, polyethylene. These all are non-biodegradable. And if we talk about biodegradable polymer PHPV, then it is formed by the monomers are 3-hydroxybutanoic acid and 3-hydroxypantanoic acids. These come together, they undergo a condensation reaction with elimination of water molecule and result in formation of PHPV. Actually, the reaction takes place between this aldehyde, this carboxylic acid group, and this group, and the resulting formation of a polymer PHPV, which is biodegradable. Next biodegradable polymer is dextron, and its monomers are glycolic acid and lactic acids. Again, these two combined with elimination of water molecule, simply water molecule is eliminated and results in formation of dextron. Another one is nylon 2, nylon 6. Its monomers are glycine, which is an amino acid, and aminocaproic acids. Glycine and aminocaproic acids, both are amino acids. They undergo condensation reactions to form nylon 2, nylon 6, which is, yes, biodegradable. Now there is a solved problem. Monomer of nylon 6 is, yes, we know nylon 6 is formed by caprolactam. And nylon 6,6 is which type of polymer? Is it polyamide, polyester, addition polymer, or homopolymer? Actually, it is a polyamide. Nylon 6, nylon 6,6 are polyamides. So students, we studied about condensation polymers, mainly polyamides, which involve nylon 6, nylon 6,6, and polyesters like dacron. We also studied about biodegradable and non-biodegradable polymers. In our next video, we will move to copolymers. So stay tuned. Thank you.